Alright, in this video we're going to go over some different types of angles that we can make with circles and chords and arcs and radii and all these different things that we can do with circles. So there are a bunch of rules here that we're going to have to remember, so I'm going to kind of walk through them one by one. We'll do some examples and try and make this make sense. So the first type of angle that you might see with a circle is a central angle. And so what a central angle is going to be is something that has the center of the circle as the kind of point of the angle here, and that is made with two line segments that connect to the outer edges of the circle. Alright, so this is a central angle because we've made a segment of the circle. You can basically think of this like a piece of a pie, right? As long as you're cutting your pie into slices that go to the exact center of the pie, that's really what we're talking about here. So the rule with central angles is that these angles have the same measure as their intercepted arcs. So what we mean by an intercepted arc is just an arc that is cut off by a certain angle that's made by line segments. So in this case, we've made this angle here with these two line segments, and so the intercepted arc is going to be this arc here that's basically what gets sliced by these line segments here, right? We have the two line segments, and the arc that's in between the line segments or lines would make the intercepted arc. All right, so that's just an important vocab term, intercepted arc, that we're going to need to know throughout this whole process. All right, so the rule here was the central angle has the same measure as the intercepted arc. So in other words, the angle that we made here between these two lines is 60 degrees. So the arc that is intercepted by that central angle is going to have the same measure, also 60 degrees. All right, so these are always going to match up if we're dealing with central angles. Okay, so we're going to talk about different types of angles here in a minute, but for central angles, the rule is the central angle measure equals the measure of the intercepted arc. All right, so we could look at another example here. This is an angle that opens up real big, 220 degrees, right? This is obviously a big angle, over 180 degrees. The rule is still the same. The intercepted arc, in this case, we made the arc using these two line segments here, and again we come all the way around here because this opens more than 180 degrees. So the measure of this arc around the outside is also 220 degrees because it matches up with the angle that's made by the central angle here. Right? So the central angle always has the same measure as its intercepted arc. All right, so that is rule number one on our list. So real quick, if you want to pause the video and try this out based on what we just learned, what is the measure of angle X in this picture? So if you want to come up with an answer on your own, basically the measure of angle X here will be 80 degrees because the angle, the central angle here, is going to have the same measure as the intercepted arc. So we have arc AB here, so angle AOB is going to be 80 degrees as well because it's a central angle. It connects to the center of the circle here. It's going to match up with its angle measure being the same as the angle of the intercepted arc here, 80 degrees. All right, so central angles are kind of the simplest one that we're going to look at. We can look at a couple more here. The next type is an inscribed angle. So what an inscribed angle is an angle that is made with 3 points on the outside of the circle. So here we have our angle made like this. So an inscribed angle is going to be something that connects to the outside of the circle where the point of the angle is on the outside of the circle just like the other points are. So with an inscribed angle, the rule is that the angle measure is half the measure of its intercepted arc. So in this case, we have an inscribed angle here, and the arc that it intercepts is 110 degrees, which again means that this arc here is 110 degrees, and that means that half of that, based on this rule, half of that intercepted arc is going to give us the measure of the inscribed angle. So here, half of 110 degrees would give us 55 degrees, and that's how we came up with this, is just doing 110 divided by 2 would give us 55, and that's how we come up with this angle. So if it's an inscribed angle, take half of the intercepted arc, and you'll find the inscribed angle. We could also do this the opposite way. If you kind of reverse this rule here and say that the arc is double what the inscribed angle measure is, right? If we wanted to, let's say we didn't know that this was 110, we could then figure that out by doubling this 55, because if the angle is half of the arc, then the arc is double the angle, right? So if we do 55 times 2, that would give us 110, which could give us the measure of this arc here. So you can go either way with this. The central angles as well, you can go either way. That obviously is a lot simpler, but with the inscribed angles, you can go either way. If you have the arc, cut it in half to get this angle, and if you have the inscribed angle, double it to get the arc. So we can put that into practice here, try and find the measure of angle X if you want to pause the video and find this out on your own. So angle X here is an inscribed angle, and we can tell that because it has, we have points of the angle that are made on the outside of the circle here. All right, so this is an inscribed angle, so we're going to use our rule and say that the arc that is intercepted here, which is in this case is 100 degrees, is going to be twice as much as the inscribed angle, or the angle is going to be half of the arc, however you want to look at it. So if we take our arc here, which is 100 degrees divided by 2, that would give us 50 degrees for the measure of this inscribed angle here. All right, so inscribed angles, again, reviewing the rule, it's just taking half of the intercepted arc or doubling the angle to get the arc, depending on which way you're going. All right, the next type of angle we might see are secant interior angles. So these are formed by lines, secant lines, that go through the circle but don't intersect in the center. I mean, this rule could be applied to angles in the center of the circle, but this is more common to see in angles that don't go through the exact center. It makes it a little more difficult. If they go through the center, they're pretty easy to do. So with secant interior angles, the rule is the angle is formed by the secant. So in other words, these angles in here are the average of the measures of the arcs that they intercept. So we have these two arcs here. We have 85 degrees that's intercepted by this bigger 65 degree angle, and then we have 45 degrees that's intercepted by this smaller, or by the same 65 degree angle, but kind of the smaller chunk of the pie here. So the rule is that the two arcs, we take the two arcs and we take the average of those two arcs, and that gives us the angle in the middle. So how we could do this is, if we take our two arcs, remember to take the average, we total up all the numbers that we have and divide by how many numbers that we have. So in this case, we'll do 85 plus 45 and divide by 2, because we're taking the average of two numbers here. So we're going to divide by 2. So 85 and 45 would give us 130. If we divide that by 2, that would give us 65 degrees. So that's how we could come up with these two angle measures in the middle here. All right, so reviewing this rule, the angles formed on the interior, these vertical angles that we get by these secant lines, are the average of the arcs that they intercept. So we're going to have two intercepted arcs here, 1 and 2. And so we take the average of those, and that gives us the measure of the angle that's formed by the secant lines. And again, these two are going to be the same because of our vertical angles postulate, right? So we have angles here that are formed by two intersecting lines. The vertical angles there, again, the angles across from each other, are going to be congruent. We've done proofs of that. I'm not going to go through that in this video, but know that these two angles here are going to be the same because of that postulate. All right, so again, take the average of the intercepted arcs, and that's going to give you the value of the secant line, or the angle formed by the secant lines. All right, so we could look at an example of this. Find the measure of angle X here. All right, again, pause the video, try this out on your own. So what we could do here is, again, just take the average of the intercepted arcs. So we have two intercepted arcs by angle X and its vertical angle. We could also call this angle here angle X as well. So these are going to be congruent because, well, we could call it angle Y, but it's going to be congruent to angle X because they're vertical angles. So we have these two intercepted arcs here. First this 70 degrees and this 170 degrees. So what we have to do is take the average of these two arcs. So we do 170 plus 70 divided by 2, because we're taking the average again of two numbers here, 70 and 170. So if we add these up, this would give us 240 divided by 2, and that would give us 120 degrees for these intercepted, or for these secant angles. So the measure of angle x would then be 120 degrees, and if we call this angle y down here, again, it's going to be congruent because these are vertical angles. So the measure of both of these angles would be 120 degrees. All right, the next type of angle we're going to look at is secant tangent angles. So these are angles that are formed, as you might tell by the name, by secants and tangents intersecting. So we have here a secant line, we have here a tangent line, and this is going to be an angle formed between those two. So the angle formed between the secant line and the tangent line is a secant tangent angle. All right, so the rule for this is that it is half the measure of the intercepted arc. All right, so here we have an intercepted arc by this secant and tangent line that measures 100 degrees. So we take half of that, and that would give us 50 degrees in here. All right, so this is kind of similar to the rule for inscribed angles, right? The angle here is going to be half of the intercepted arc, and again, this is for secant and tangent lines that form an angle. So again, this works both ways. If you have the angle for the secant and tangent angle, or the angle formed by secant and tangent lines, you can double it to get the measure of the intercepted arc if you were asked to kind of work backwards there. So a practice with this, here we have a tangent line BC and we have a secant line AB. Find the measure of angle x based on this arc. So again, pause the video, try this out on your own. So what we have here is we have the measure of the intercepted arc as 120 degrees between this tangent line and this secant line. And so to find an angle x, we just use the rule and we take half of the measure of the intercepted arc. So we have 120 degrees divided by 2. That would give us 60 degrees for angle x, being the interior angle between the secant line and tangent line. All right, and the last type of angle situation we're going to look at here are exterior angles. So the word exterior means outside, right? So we're looking at angles that are formed outside of the circle. So there's a few different types of exterior angles that we're going to look at here, but the rule is the same for all of them. The measure of an exterior angle is half the difference of the two intercepted arcs. All right, so we can look at this here. We'll break this down a bit. So this is our exterior angle here, right? It's exterior, it's outside the circle if we're looking at this piece of the angle here, right? So we have an angle that's formed outside the circle, so it's an exterior angle. And so to find the measure of this exterior angle, we have to take half the difference of the two intercepted arcs. So the two intercepted arcs formed by this exterior angle, right? If we extend this out here, right, we see that we end up with two arcs formed, right? We have one arc here formed by kind of the continuation of this, and then we have one arc here where the lines first intersect with the circle, right? So in order to find the angle here, this 20 degrees, how do we come up with this? Well, we take half the difference of these two intercepted arcs. So if we take the difference, meaning subtract them, right, we would do 65 minus 25. So it gives us a difference of 40. And then we have to take half of that. So we would divide that by 2, which would give us 20 degrees, which matches up with the value here, right? So this would be how, if we didn't have this number, we could calculate it based on the two intercepted arcs that we have. All right, so we take the difference and then take half of that. So in other words, we subtracted 65 and 25, got the difference between those arcs, and then took half of that here, and that's how we ended up with this 20 degrees at the end. All right, so that is one specific example here. If we look at what we had here, we had two secant lines that formed these this exterior angle here. All right, so this is kind of like case number 1 here, right, where we have two secant lines that form the intercepted arc. What we can also look at is a slightly different case over here, right? We have two lines that connect to points on the circle, right? In this case, these are two tangent lines. So if we have two tangent lines, then we're going to use the same rule here, half the difference of the intercepted arc. So this looks a little different than this other one, right? But we still have this exterior angle here that's formed on the outside of the circle, but the rule is going to be the same. We're going to take half the difference of the two intercepted arcs. So if we look at these 2 points here, right, we have an intercepted arc of 80 degrees here, and then if we go down and measure the bigger arc on the bottom, right, we have 280 degrees for the larger arc, right? If we weren't given this 280 degrees, we could easily find it because we know that there are 360 degrees in a circle, right? We have 80 degrees here, so the rest to get to 360 would give us 280, right? So that's kind of a sidebar, but we did we were given both of the angles here, so that's kind of irrelevant. So what we have here is two angles, 280 and 80 degrees, and so we can find half the difference in order to get our measure of 100 degrees for the exterior angle. So we can try this out and confirm that this is actually correct, right? If we do 280 degrees minus 80, that would give us 200, and then we want to take half of that difference. So if we divide that by 2, that would then give us 100 degrees, which again matches up with what we were given here. All right, so again, if we didn't have this angle, we could find it using the rule for exterior angles. We could take half the difference of these arcs. Again, 280 minus 80 gave us 200. Divide by 2 to take half of it, that gave us 100 degrees, which again matches up with what we had here. All right, and we have one last case here. This is a line formed by a secant and a tangent line, right? But again, this is an exterior angle, so we're going to use our exterior angle rule. All right, so this angle, we're going to take half the difference, again, of the two intercepted arcs. So we have our arcs here are 180 and 80, right? So we can take the difference of those. 180 minus 80 would give us 100. And then again, we're going to take half of that difference, so we will divide it by 2, which would then give us 50 degrees, and that matches up with the 50 degrees that we were given for this exterior angle. So these are all slightly different cases with exterior angles, right? Here we have two secant lines, here we have two tangent lines, and down here we have a secant and a tangent, but the rule is the same for all of them. It's going to look slightly different, but each time we're only taking half the difference of the two intercepted arcs, and this works for any of these exterior angle cases. All right, so we're going to do practice with this here. We have a few different cases with exterior angles, so if you want to find angle X for each of them respectively, pause the video, try this out, and we'll go through them one by one. So what we have here is an exterior angle formed by two tangent lines. So we have the two intercepted arcs, right? So we're going to take half the difference. All right, so half the difference of the intercepted arcs is going to give us angle X here, right? So if we go ahead and calculate this, we have 260 as one arc that's intercepted here. We have another arc that's intercepted is 100 degrees. So if we want to calculate this, we subtract them. 260 minus 100 would give us 160, and then we have to take half of that difference. That would give us 80 degrees. So the measure of angle X in this case would be 80 degrees. We can come up here and try the next example. Again, we're going to take half the difference of the intercepted arcs. So we have angle X here. We have our intercepted arcs of 80 and 20. So we're going to take the difference of those, which would be 60. We have to take half of that divided by 2 would give us 30 degrees. Ignore my shorthand here. You can kind of see as I'm doing it, this isn't a valid equation, but just kind of follow from left to right here. So we get 30 degrees for angle X in this case. And down at the bottom here, we could do the same thing. We have two arcs, 100 and 30, so we'll subtract them, get 70, cut that in half, which would then give us 35 for the measure of angle X here. All right, so three different cases, but again, they're all exterior angles. If we look at each of these angles, right, we have an exterior angle in each of these cases, right, that's outside the circle. So the rule for all of those, whether they're formed by secants or tangents or both, is that we're going to take half the difference of the intercepted arcs. So for each of those here, we subtracted the difference between the arcs, cut it in half to take half that difference, and that gives us each of these exterior angles. All right, so hopefully we're kind of getting the hang of this by now. We're going to do some combined practice problems here and kind of put together some of the things that we've learned here. So here we have measure of arc AB is 90 degrees, measure of arc AC is 160 degrees, and we want to find the measure of arc BC and also angle X in here. All right, so this is kind of putting together some different things if you want to try this out on your own and come back for the answer. So what we can do here is use our inscribed angle rule, right? So we have an arc here, 90 degrees for the measure of arc AB, right? This would be the intercepted arc for the inscribed angle down here, angle C. So again, with inscribed angles, we know that the angle is half of the intercepted arc. So we have 90 degrees here. If we take half of that, that would give us 45 degrees down here for angle C. We could do the same thing for angle B. We could find the measure of angle B because this is another inscribed angle, right? Angle ABC here is an inscribed angle with the intercepted arc here 160 degrees. So again, for inscribed angles, we take half of the intercepted arc. So this would give us 80 degrees in this case for angle B. So we have 80 degrees, we have 45 degrees, and we have a triangle formed here, right? So we can easily use our rule for triangles that we know all the angles in a triangle add up to 180 degrees. So we could say 180 degrees would equal 80 plus 45 plus x, because those are the three angles of our triangle ABC here. Right, so we know these three angles have to give us 180, so we can set up this equation here, right? And if we go ahead and solve that, we would end up finding out that x would be 55 degrees, right? We could subtract 80 and 45 over to the other side and find out that x would be 55. That's what would give us 180 degrees when we add all of these three angles together. So we have angle x is 55 degrees, and then it asks us to find the measure of arc BC as well. So this is going to be using our inscribed angle rule again, except now in the opposite direction. We have the inscribed angle here. We could then find the measure of arc BC by doing double of this inscribed angle. So this would give us 110 degrees for arc BC. All right, so this again, to get from here to here, we used our inscribed angle rule. The angle is half of the arc, or the arc is double the angle. All right, so this was one way to approach this problem. We could also kind of work the other way, right? First we found the angle and then the arc. We could also use what we know about circles to find the arc and then the angle, right? So we know that there are 360 degrees in a circle, and we have three pieces of the circle here, right? Three arcs that make up our circle. So we know that this arc, and arc BC have to total up to 360 degrees. So we could do that and find the measure of arc BC by doing 360 equals 160 plus 90 plus, let's call this arc Y. So we know 160 plus 90 plus Y would have to give us 360 degrees, because those are the only arcs that make up the circle, and if we add them together, they have to give us the total number of degrees in a circle, which is always 360. So we could again solve this. We would find by doing it this way that arc Y would be 110 degrees. And then we could find angle X, because angle X is an inscribed angle that has arc BC as its intercepted arc. So we could take half of this 110 and get 55 degrees for angle A. All right, so if you are great with your triangle rules and you could use the three angles of the triangle adding up to 180 like we did in the first method, that's great. If this way seems easier to you, this does end up being a few fewer steps depending on how you look at it. So this is another way that we could have approached this, right, by finding the arc and then solving for the inscribed angle. All right. So this is an example that uses the concept of inscribed angles. We're going to look at another one here. So here we have an inscribed angle, and we also have an exterior angle. We're told that the measure of arc AB is 45 degrees, and we want to find the measures of angles x and y. We also have this arc here given to us as 120 degrees. All right, so using that information, try and find the measures of angle x and y respectively. Again, try this out on your own and come back for the answer. So what we're going to do here, we have an inscribed angle, angle y. That's a great place to start. We have angle y as an inscribed angle. It's going to be half the measure of its intercepted arc. So angle y would then be 60 degrees because that would be half of this intercepted arc, 120 degrees. All right, so angle y, pretty easy to find here using our inscribed angle rule, 60 degrees, half of this intercepted arc. So we also know that this other arc here we were given is 45 degrees, and we're going to need that to find angle x, because again, for exterior angles, which this is, we have to take half of the difference. So we take half of the difference of these two arcs, and that's going to give us angle x. So the intercepted arcs that we have here, again, the second one and the first one, so we have 120 minus 45. So we take the difference of our two intercepted arcs here. This would give us 75, and then again, half of the difference. So we're going to divide that by 2, which would then give us 37.5 degrees for angle x. All right, so we had to use two rules here. Our inscribed angle rule, right, that the angle is half of the intercepted arc, and we also had to use our rule for exterior angles, which is taking the difference. So we had 120 and 45 as our two intercepted arcs for this exterior angle. We subtract those, that gives us 75, divide that by 2, and gives us 37.5 for half the difference of those intercepted arcs to get the exterior angle measure here. All right, and one last practice example here. We have a triangle here formed by ABC. All right, and so we're going to try and solve this triangle based on some information that we're given here. All right, so we're told that the measure of arc BD is 70 degrees, so that means our arc in here is 70 degrees, and we have the measure of arc BC is 140 degrees. So we're given two arc measures here, and what we have to do with that is solve for all of the angles of triangle ABC. All right, so this is going to be a little bit tricky, but still very doable. Hopefully this is kind of the culmination of what you've learned in this video, if you can piece all these things together and solve for triangle ABC here. So again, the angles that we're looking for in triangle ABC would be angle B here, angle A over here, and angle C over here. All right, so if you want to try this out on your own and come back for the answer, hopefully we're all on the same page now. So what we're going to do here is kind of try and walk through this step by step. So we have an arc here that was 70, and we have an arc here that was 140. So a few things that we could do here. There's a ton of different ways to approach this problem, but we're going to try and walk through kind of the easiest way to do it. So the first thing here, we have an inscribed angle, angle C, and an intercepted arc here, BD. So that's the first thing that we could do, is use our inscribed angle rule and know that angle C is going to be half of this intercepted arc. So that would be 35, because we would just divide 70 by 2, and that would give us 35 degrees for angle C. Forgot to label my degree signs here, right? But so angle C here we know would be 35 degrees. What we could also do is use our rule for our rule for exterior angles with angle A. So we have an arc here 70 degrees, we have another arc here 140 degrees. Those are the two intercepted arcs by this exterior angle formed by this line here and this line here, right? So we could go ahead and use that rule, taking half the difference of these intercepted arcs. So the difference would be 140 minus 70, that would give us 70, and we could take half the difference, divide that by 2, which would give us 35 degrees for angle A as well. All right, and then we could use our triangle rule to solve for angle B, right? If we know that angle B and these other two angles have to add up to 180, we could then say we have 180 equals 35 plus 35 plus b, right? So we know this angle, and angle B have to add up to 180 degrees because they're the three angles of our triangle, right? So we could solve this and we would get B to be 110 degrees. All right, so we can solve that here, and we could also figure out that in this triangle, we know that angle, we have these three arcs, right? We know that this angle, or this arc, and this arc should add up to 360 degrees, right? So we know that we have 110 degrees for, oops, I'm all mixed up here. I'm just gonna stop it there, and hopefully we've managed to solve this. It's been a long video, and as you can tell, my brain is losing function. So thanks for watching this video on all these different types of angles, and I hope you've learned these rules. Again, just try and learn each of the rules and figure out how to apply them, and hopefully with this last example, we really put that together with a couple of different measures here. All right, thanks for watching this video, and I'll see you in the next one.